In real world, data never stays the same. Rows keep getting inserted, updated, and deleted. So if we process the full table every time, of course, it is going to work, but it will be slow and very costly. Streams help us process only what changed, not the entire table. In this video, I will explain streams from scratch and then show you how exactly insert, update, and delete behave. So what is a stream? A Snowflake stream is basically a change tracker. It keeps track of row level changes in a table since the last time you read the system or you read the stream. And it's very important to note that a stream does not store data. It only tracks changes, right? So once you read from a stream, Snowflake moves the pointer forward. So for example, if you have read some data, right? If you remember file in file pointers, right? There's a seek pointer, right? So if you keep on reading the data using that pointer, it keeps on moving up, right? So that's why once you read from a stream, Snowflake moves the pointer forward. Whenever there's a change in a table, Snowflake records it with some metadata, right? And that can be, let me show you, that can be metadata action. If metadata action, so this is a metadata column that we usually get in Snowflake metadata action. If it can be insert or delete, and there's another metadata column called metadata is update. This one tells you whether this change is a part of an update or not, right? We can do insert query, delete query, and update query, right? Updates are a bit special in Snowflake, right? Why? Because when you update a row, it creates two insertions, right? Two action actually. One is it will delete the old row, and then it will insert the modified new row with the modified data, right? So it creates two actions here, delete plus insert. So that's why update is a bit special in the Snowflake. This is most important thing to remember in case of streams. I will let you know why does it actually matter to handle updates with care in streams. Okay, so enough with theory. Let's jump to some practical. Let us create a table. Okay, so right now I'm using account admin. Let me switch to some different role. I don't know, I didn't create any role for now. Let me use Snowflake running row. I hope I have access to this one, and I'm using this one computer. Let me use a database. Let me create a database now. Create DB. uh what should I know? Snow DB. Let me just name it some random Snow DB, right? Create database. Okay, my bad. Okay, I'm giving so much of typos here. Okay, so create database. Data is created. Now I'm going to use this database. You can do directly from the drop down here, and let's uh, let's use schema public for now. Okay, I'm going to create a new table. Let me create an employee table called employee. It has employee ID, name, salary, department updated. Don't care too much about the what exactly is going to this table. Just okay. Let's run this one. Okay, seems like I don't have. Okay, why am I again on account admin? I should be using this one, right? Oops, 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 oops. I don't know what happened. Let me use account admin for now because I have not created roles in my current account, right? I need to create a correct role and then assign the accesses to that. For now, let's focus on streams right now. I'm not going to create roles about this one. Okay, so I've created a table called employee. Okay, let's insert some data into it. So I'm inserted. Let me anything, right? Current timestamp, Rahul, two names are there. Let me run this one, right? It's inserted two data, two rows into the table. Let me do some select a star from this table, select a star from implies, right? So you can see that we have two rows here, right? Okay, now let us create a stream, right? Okay, stream over this table. So streams are created over base, right? And base can be table. Here our base is table, implies table, right? So the syntax remains same: create or replace stream, name of the stream on the table that you are going to create, right? Let me create this one. Okay, it shows that stream is created, right? Now what I'm going to do is let me query this stream. Okay, so I'm selecting the columns here, employee name. So these are the columns. So when you create a stream over the table, right, so whatever column is present in table will be automatic. You can call that one through stream 2, right? These columns you can be accessed via streams 2. So right now I'm just using 3, and then the two metadata columns, right? Metadata action and metadata if it is an update. Let me just run this one to show you. It shows nothing for now, right? Because why, you must be thinking, okay, you inserted some row, right? But why it's not getting visible in the employee stream? Because we created stream, employee stream, after the insertion, right? So the stream didn't track any change. But now we have created the stream, right? And now whatever changes we will be doing to this table will be tracked by the stream. Let's do some insert, right? Let me do some insert again. So I'm inserting this one row, right? Let me now run the stream query now again. You can see, right, it tracked that employee ID was 3, name was Aman, salary was this one. What was the action here? So we did insert, right? So it detected, okay, this was an insert option, and whether this was a part of update or not. So it says false, which is correct, right? We didn't update any row right now. It was just an insert, right? So streams only show data that changed after it was created or after the last read, right? Okay, now this was an insert operation. Let's see what happens when we delete a row. Let me run this query. Delete from employees where employee ID was 2. If you remember, employee ID 2 was Rahul, so this one is going to delete it. Let me run this one. Okay, now let me again go and query my stream. So you can see now it shows we have right now two rows here. One was for insert, right? If you remember, we have inserted it, but we have not consumed this data right now. So that's why it's still present in our stream, and it shows metadata action as an insert. And this one for employee ID 2, this one is a delete option, and it is present in our stream, right? Okay, now let's see a situation when we do some update, right? Because these all are real world examples, right? We keep on updating, deleting, and inserting the data to some tables, right? So what I'm doing is, for employee ID 1, what was employee ID 1? For employee ID 1, uh, we are updating the salary, right? Or yeah, we are updating the salary, and then we are marking the updated ad as current timestamp, right? Let me run this one, right? So it shows that row number of rows updated 1, number of multi-join rows updated 0. It won't swing. Let me 0, right? So let me again go and query my stream here. What does it show? Yep, look at it. So remember what did I say? Where told you, when we do an update operation, right, in Snowflake, it is being, it is it get treated a bit special, especially special, right, in Snowflake, right? Why? Because if you look at it here, right, I changed the salary part, right? For row number employee ID 1, what did you do? It created two operations, one for insert and one for delete. Why? What's meant by delete here? So it is in deleting the old instance of the row, right? And it will delete that row, and the new row that was created, right? Like we updated salary, right? But it will keep all of the information together with the new updated column value, and it will mark it as insert, right? So two instances, one for insert and one for delete. And if we see here, metadata is update is going to show us true, right? So these two options are coming as true. What does it mean? It means this these two rows is a part of update, right? Cool. Together these two rows, right, represent a single update operation. And if you will not take care of this particular column, metadata is update, your stream is going to mess your data, right? Because if you're just going to take action based on metadata action, right, and you are thinking, okay, my data is going to get updated, but in place it might get deleted, right? So yeah, take handle this one with care. Now, right, now we have done three operations already: insert, delete and update. Now how to use this one, right? All of the changes are tracked in this stream table, but till now we have not used it. Okay, so what I'm going to do is I'm going to create a new table called employees curated, like. And if you look at that this syntax, right, I think you might be most of you, like few of you are you are might be familiar with the syntax, but yeah, if you're not, let me just tell you what exactly do. So create or replace will obviously, if the table is present, it will replace it, and if it is not, it will create it. This is the table name. And like implies, right, what does like does it, like it will copy the schema, like copy the a schema for the implies table from, like if we have some parts, if we have some cluster key, it will copy that one. If we have primary key, like it tries to replicate the same table with different name without data. The table will be empty, right? Let me run this one, right? Let me show you that it we our table is right now empty. Look at this one, right? Our table is empty, correct? Now let me write a merge statement, right? Merge into employee curated, right, using employee employee, let me just copy paste, I might employee stream, right? Let me just give some aliases, target, and this will be my source. Let on target dot, because employee id is kind of primary for us, right? Primary key for us, so I'm running on employee id source dot employee id, right? Now merge, so right now I just created a relation there, right, using join. Now what do I want to achieve here, right? Then I will write when matched, when the records are matched based on this condition, what I'm going to perform, when matched, and source dot, remember this key, right? Remember this key, metadata action. Now I'm going to use this one, right? And source dot metadata data action is equal to delete and source dot metadata, let me just copy and paste, metadata is update is equal to false. So what I'm saying here, I'm saying when this record when this condition matches, means the target id, target employee id and source employee id is same, right? And the source metadata action is delete, means I have metadata action is coming delete, and metadata update is false, right? This means this condition is looking for delete statement, right? Only delete statement. Remember, I have marked it as false. This one will make sure that I'm not picking delete record that was coming from update a statement, right? So this one looking for delete a statement, right? Correct. Now let me just copy this one again, and I will make the changes to this one only. Now when, right, when matched, right, when matched and source metadata action is equal to insert, right, and metadata is equal to true. Now look at it. Now look at what I'm doing here. So what does it mean, right? Okay, I didn't tell it what to do. Then delete means if it match, if there is a delete student, just delete the data, right? Delete the row where this condition is satisfied. Delete. And for this one, okay. Source metadata action is update is true. If you remember, what does it say? This means I am targeting now update a statement, right? Update statement true. Then now what I should be doing? What action should I perform? Update, right? Then let me put set salary is equal to source dot salary, right? I'm going to update the target salary from the whatever is coming from our stream. Source of salary department is equal to source dot department, like whatever updates you think you would be doing, you can put it here. And then what I can do is like I'm also going to do updated at is equal to source dot updated at, right? This will target matched, right? Now listen carefully. When not matched, what does it say? It means this will be a new data, right? Means insert, right? If data is new, it's not matching in any case, right? When not matched, obviously if source employee ID is not present in target employee ID, which that would be a new data, right? So in that case, when not matched and source dot metadata action is equal to insert. So if there is insert a statement, obviously that would be new, right? If that one is that implied is not present in our source in our target date table, we are going to add it to our target table, right? With function, then insert. Now I have to write insert a statement here. Insert emp id, give the column that you want to insert, emp id name salary department updated at I think that's all the column that I have, and the values, right? So the column name is same as coming at the target, just I need to add source before that because I asked the source source. Yeah, right. So let's revisit what we did here, right? So we are creating merge statement to our our new table that we created here for use created employees using the employees stream that we created. Okay, uh, employees stream that we created, right? And we are matching condition on employee ID, right? So first statement is when matched, right? When we have employee ID coming that is coming from, for example, let's look at the example. In source in a stream we have employee ID as 1. The same thing in target table we found the employee ID as 1, right, and the metadata action is coming as true. Metadata action is delete, right? So we're saying, okay, when matched, right, if the employee ID is equal to 1 is present already in target, when matched, and the metadata action that was coming from the stream is delete, right? Also we have to check whether it was a part of update or not. If it was part of not part of update, then we're going to delete it, right? This one targets the delete statement that we did. Then for update statement, remember, so it handles two part, right? Insert and delete, right? So we are checking if IDs are matched, right? One is present and action is insert, okay, but metadata is update. is true, right? Then what we're going to do, we are going to update our data. We are going to set salaries to whatever is present in our source department, updated at this one, right? And then the next part targets the insert statement, right? The insert statement, like if the keys, if the employee ID, for example, if we have in a stream we have 10 and it is not present in the target table, right? So it will say, okay, this key that is not did not match with any of the key present in target. So when not matched, and if the action is insert, then run this query, insert it, right? So this one handles inserts, updates, and deletes correctly. Okay, this and this is also how we do this thing in production. Okay, this is not just some dummy statement that I'm going to that I'm showing you. It happens exactly like this in production too. Okay, so let me run this. Okay, it says some uh, invalid identifier target.empid. Okay, let me see what I is there, right? Implied is there already. Emp. Okay, my bad, there was some typo. I run it, right? Now it shows me number of rows inserted 2, number of rows updated 0, 0, right? Now let me look at my employee created table. It inserted 2 rows right now. Okay, now look at what happened to our stream table. Look, we since we consumed the data from our stream, right, the data is gone now. Remember, the data is gone, right? Because we already read it. So the pointer is now pointing to end of the file. All of the previous data, previous log is gone from the stream, right? Okay, now let's again do some query over created. So it says employee ID1, employee ID3, right? Okay, let's now run a delete statement from let me delete employee ID is equal to 1. Okay, so I'm deleting from our base table over which our stream is created. I'm deleting employee ID 1. Let me delete this one, right? Now let's look at our stream. What exactly it shows? It shows delete, right? Employee ID delete. Now look at our created table. It has 2 rows, right? Employee ID 1 and employee ID 1 and employee ID 3. Now think about it. I'm going to run again this query merge statement. What do you think will happen to it, to our created table, right? So let me look at it. It shows number of rows inserted 0, number of rows updated 0, number of rows deleted 1. Why? Because in our stream there was a row, right, where source metadata action was delete, right? And since the employee ID was already present our target, so this action was performed and our our row with employee ID 1 was removed, right? Let me query again. See, employee ID 1 is gone from the table, right? Now if I will again look at the stream, it will be having no data, right? All is gone because we have read the data, right? So after consuming, the streams becomes empty, right? The stream becomes empty. That's because Snowflake moved the pointer forward. Now the question is when to use streams, right? Use it when we are creating incremental pipeline, when we are capturing changed data, we are capturing changing data inside a Snowflake, and when we are creating SCD, right, where we are creating slowly changing dimension, and when we are trying to replicate near real time processing, right? Because as soon as you change some data, right, it will be getting it gets reflected to the streams, right? So it gives us near real time changes, right? So okay, and also when not to use, right? Don't use it when you want to full refresh, right? Full refresh a table every time. And like if the table is very small and you can do full refresh, right? Never use stream. You can handle it full, right? And also if the table never changes, right? If the table never changes, you don't need to don't need to use it, right? Because if there are very few changes, why would you need to use a snow streams, right? You can capture the changes through via a different method, right? There's one thing to note is streams gets expired in 14 days. Okay, so if there is no change to your source table over which the stream is created for more than 14 days, the stream will get stale or expire, right? Meaning it now it's in bad state. It is not going to capture any changes in the data. You have to recreate the stream to get it activated, right? So keep that thing in mind. So Snowflake streams are one of the most important feature for modern and ELT pipelines, right? Because right now many companies are using streams to capture the change data, and right, because what happened, not every table has some column using which we can create incremental model. It does not all of the table has uh, some created at column or some updated at columns, right, using which we can track the change data, right, to create incremental model. So streams in those cases are very helpful, right? Yeah, I hope you have enjoyed this video. You have got to learn few things. Please subscribe to my channel. Thank you. Bye bye.